This lesson is going to be about complex numbers, and the diagram that I have here is just showing you a relationship between some of the sets of numbers. Your complex numbers consist of real and imaginary numbers both. Now there's a lot of other subsets of numbers under real numbers that you're used to hearing. Rational numbers, irrational numbers, integers, whole numbers, natural numbers, those are all subsets of your real numbers. But these two sets of numbers don't have any numbers that are shared between those. But we're going to look today at some different things that you can be asked to do with your complex numbers. All right, this slide, just write these notes down here. When you're dealing with complex numbers, that's going to be any number that can be written in the form of a plus bi. So all real numbers, all imaginary numbers can be written in this form. That's what's referred to as standard form. So you'll hear me mention that several times. All right, these are two equivalencies here that we're going to use also with some of these problems. I is considered your imaginary unit. So when you're dealing with imaginary numbers, you're going to be seeing the I. That's kind of what gives it away as being an imaginary. But I is defined to be the square root of -1. Now from this statement, you can get this one by squaring both sides. So that would mean that I squared is equivalent to -1. Okay, first thing that we're going to do is just look at adding and subtracting of complex numbers, and then we're going to be asked to write our answer or make sure that we put our answer in standard form. Now, since we have subtraction here, what you're used to doing just with polynomials will be to distribute the minus sign, so that will need to be your first step with this problem. So I would have 7 plus 9 minus 2i plus 17 plus I. Now once you distribute your minus signs, it's just a matter of combining like terms. So your real parts, that would be the 7, the 9, and the 17. So if you add all that together, you're going to get 33. And then your imaginary parts, which would be the -2i and the 1i, so you combine those together and you get a -1i. Now the 1 would be understood to be in front of the I, you don't have to write it. But this would be considered the standard form that it was asking you to write your answer in. So you've got to make sure that you have the real part and then the imaginary part. So this is that A plus BI form that I was talking about earlier. Okay, next we're going to look at a multiplying problem, and again you notice it says write your answer in standard form. So again, when we're finished, we want it to look like A plus BI. Now going back again, I keep comparing these to polynomials, but any time in the past you've seen two parentheses side by side like this, you've used your FOIL method. That's exactly what you're going to do here. Okay, so let's start FOILing this out. So 8 times -3, so we'll get -24. 8 times 9i, so 72i. -4i times -3, so positive 12i. And then -4i times a positive 9i would be -36i squared. All right, two things that we can do in this next step. First of all, you can combine the two terms in the middle because they're considered to be like terms, these two. So I've got my -24. Of course, 72i plus 12i is going to give us 84i. Now the other thing we've got to do is replace the I squared with -1. And that goes back to one of those equivalencies that I had you to write down just a few minutes ago. I squared is equal to -1, therefore you can make that substitution. Because if we're trying to write this in standard form, if you go back and look at the standard form, it doesn't have an I squared in it. So that's how you take care of that situation. Okay, so I've got -24 plus 84i, and then you do the multiplication here, that's going to end up giving you a positive 36. Okay, now last step, you do have these two just being real numbers, so you can combine those together. So that's going to give us 12 plus 84i. So this is your final answer, and it is written in the standard form that was asked of you. Okay, next, we're going to look at dividing. And it's not so much that you're dividing, like how much will something go into something else, but it is division because it is a fraction. You have a complex divided by a complex, but we're just going to go through a process in order to get it in this standard form. Okay, you're going to use what's called a complex conjugate. You need the complex conjugate of your denominator, and all you have to do to get that conjugate is to change the sign in the middle. So my conjugate is going to be 4 minus 3i. And what we're going to do is multiply the numerator and the denominator by that complex conjugate. Okay, so going back to multiplication, on the top, we need to FOIL this out. So you'd start with your 3 times your 4, 3 times negative 3i, and then do the same thing to get the other two terms. Okay, so I'll have 12 minus 9i minus 16i plus 12i squared. Okay, now we'll also FOIL out our denominator. So 16 minus 12i plus 12i minus 9i squared. All right, so we're going to have to do some of the same stuff that we did with the previous problem. The two terms right here in the middle you're going to be able to combine. So I have 12 minus 25i, and then I'll replace the I squared with negative 1, so I'll have plus 12 times negative 1. All right, do those same steps on the bottom. But when I go to combine these two terms in the middle in my denominator, they're going to add out. But I also replace the I squared with negative 1, so I've got my 16 minus 9 times negative 1. Now this is going to end up being the same thing as a negative 12. So you have 12 minus 12. Those are going to happen to add out. They may not. That just varies from problem to problem. So I have negative 25i left on the top. Same thing here. You multiply these two together. A negative times a negative is a positive. So this is the same thing as just 16 plus 9, which is 25. And then you can reduce the 25s. Therefore, you're left with just negative I. Now, that is considered to be standard form. But when you look at it, like a plus bi, your a in this case is just an understood 0 and then minus 1i. But of course, you don't have to write all that. I mean, this is your answer, but that's why it is still considered standard form. Okay. Now, just going back to some other types of problems, then again, it's asking each time standard form. Now, what we have to deal with on these problems is the fact that we have the negatives underneath. So here's how you handle that. When you have a negative number underneath, you're going to separate that negative with a negative 1. Now, just like you've been taught in the past to simplify radicals, you want to find the largest perfect square that will go into 8, which happens in this case to be a 4. That would be 4 times 2. Okay, then you'll want to do the same thing with a negative 18, so we're going to separate the negative, and the largest perfect square that will go into 18 is going to be 9, so that'll be 9 times 2. Okay, so I've got my 5. Now, the fact that it's in front, that's right there is understood to be multiplication. So let me just put me a dot here to show my multiplication. The square root of negative 1 I defined for you back earlier. The square root of negative 1, remember, was just I. That's what I had you to write down earlier. So the square root of negative 1 is I. And then I'm going to have the square root of 4, which is 2. And then this 2 will just have to stay underneath your radical. And I'll come back and kind of clean that up in the next step. Okay, same thing here. 3 times square root of negative 1 is I. Square root of 9 is 3. And then this 2 will have to stay underneath. All right, now out front right here, let's go ahead and multiply. So that'll give me 10i square root 2. Multiply here, so I get 9i square root 2. Now on this one we can go another step. Sometimes you can, sometimes you can't. But going back to your radicals, if you remember, when it comes to adding and subtracting, the number under your radical has to be the same in order for you to add. So you can add these together and you'll have 19i square root 2. Okay, now again, when you're talking about the standard form, you have just the bi. Remember, a plus bi. It's just in this case, the a happens just to be a 0. So you ending up with just this part right here is perfectly okay when it comes to asking for standard form. Okay, next. All right, now when you have parentheses to a second power, a lot of the times, you're used to immediately writing it down twice and pulling it out. Before you do that, though, we've got to take care of the square root of the negative. Remember, I told you that a while ago. Take care of square root of negatives first. Okay, so I've got -5 minus. Now, if you need to break it apart like I did a while ago, but I don't bother breaking down the 9 because the 9 is already a perfect square. So the square root of -1 is I, square root of 9 is 3, so that's just a 3i. Now, since this is squared, that does mean that you have 2 of those. So you can write that down twice, and you're going to FOIL it out. So we've already done that a few other times. So 25 plus 15i plus 15i plus 9i squared. Okay, we can combine the two terms in the middle. And we need to replace the I squared with -1. Okay, now this is just going to be the same thing. Positive 9 times a -1 is just the same thing as minus 9, so just do your 25 minus your 9. So we're going to have 16, and then the plus 30i. So there's your standard form for that one. Okay, next. Okay, now again, I've got square root of a negative. I've got to deal with this first. So -15 minus, now I had -18 that I did earlier, so that's -1 times 9 times 2. So the square root of the 9 gives me 3, square root of the -1 gives me I, and then the 2 has to be left underneath, all divided by 33. Now this is not one of those that a dividing problem where you have to use the conjugate like we did earlier, because you don't have a complex, you don't have a number on the bottom, a plus bi. It's already just a real number. The only thing left that you can do is all three of these numbers you can reduce by 3. Now only reduce if you can reduce all 3 of them. Don't ever reduce this one. So I would have -5 minus I square root 2 over 11. And one other thing, it's technically not in standard form until you split this into 2 separate fractions and your real and your imaginary parts are separate. So -5 elevenths minus square root 2 elevenths I. Now you can leave the I on the top, but it's just kind of standard to put it beside it when there's a fraction. Okay, one more. Again, I've got square root of some negatives here, so that's the first thing I need to take care of. So this would be square root of -1 times 4 times 3. Underneath right here, that would give me square root of -1. And again, I wouldn't break up the 4 because it's already a perfect square. Of course, this one wasn't negative, so I just transfer it down like it is. Okay, simplifying here, I would have 2i square root 3. This would be just 2i minus square root 2. Okay, now we're going to use our distributive property, and we need to distribute through. So when I multiply these two, I'll have 4i squared, square root 3. And then when I multiply these two, I'll have minus 2i square root 6. When you're multiplying, you just multiply the numbers underneath. Okay, you've got to replace this with -1. So 4 times -1 square root 3 minus 2i square root 6. So this is just a -4. And there's your final answer. Okay, so that's the end of that lesson.